Alright, we're starting with 11.12. The effects of changing dimensions. So we've previous 11.1, 11.11. I mean, we did the changes in the ratios from a to b to a squared to b squared to a cubed to b cubed. So if we have all those, we should be able to tell like what's happening in between depending on what we do to any type of dimension. So if we change any dimension and we change any a, we should be able to tell if I'm going to go to surface area, I deal with power of 2. If I'm going to go to volume, I deal with power of 3. So let's deal with surface area examples first. If we change any dimensions, so if we're doing surface area, that means we're dealing with power of 2. So let's do number 1 as an example. Say if the dimensions of a figure are doubled, that means if they are multiplied times 2, how many times larger will the surface area be? Well, we're talking about surface area. So that means if we're going to do times 2, then it's going to be 2 to the second power, or 2 squared, because that's surface area. So it will always be 4 times larger. So let's go to number 2. Here we're given surface area is 62 centimeters squared. If we multiply the dimensions by 5, what will be the new surface area? Well, we know a squared, and we know that the original dimension is 5. Well, if I'm going to go from there to there, I'm going to power of 2, which means I'm going to power of 2, 5. 5 squared ends up being 25. This is my change, so I will input it and I will multiply it. 62 times 25 and get my new one. We go to number 3, dealing with surface area. Here is my surface area calculation, 736 inches squared. The dimensions are multiplied by 1/4. We're dealing with surface area, so that means 1/4. We are dealing with surface area, so we have to power of 2. Gives you 1/16. Here's our original. Here's the change. We multiply those two, and that is our answer. Now, if I give you 2 surface area, I give you the larger one, and I give you the smaller one, cone A, cone B. How much larger is it? Well, we're dealing with surface area, so that means we're dealing with a squared, right? We set up the ratio, 1422 cone A over cone B. We get our answer, but this again, this is equal to a squared. I need to get to a. This is my final. So if I'm going to get a, I got to square root both sides. So square root of 9 is 3, square root of a. This is how many times larger. Alright, now we're on to volume. If we multiply the dimensions, okay, so if we're going to volume, we're now going to work with a to the power of 3, which means any change is going to be to the power of 3. So if I'm multiplying the dimensions by 4, well, I'm actually multiplying the entire thing by 4 to the third. 64 times larger. For number 6, again, we're dealing with a to the power of 3. We have the volume of a figure, 110.5 feet cubed. if I change the dimensions, if I double them, in other words, if I multiply times 2, what will be the new volume? Well, here's the original. I need to multiply it times, well, the change. But the change is here. This is the original. 2 is a. I want to go to a cubed. If I go a cubed, that means I cube a. That means if I cube a, I have to cube the 2. 2 to the third is 8. There he goes. Multiply those two, and you have your new volume. All number 7 does is it does the same thing that number 6 did, except that it gives you a fraction. You're going to end up multiplying, you're going to get an answer anyways. You're going to cube that dimension or that change. So we go to number 8. Number 8 is similar to number 4. Okay, so they give you your solid A, okay, and we're going to compare it to solid B. So we have the two comparisons. We have the area of solid, or the volume, my bad, of solid A. Ah, I did it backwards. I didn't read all the way through. It asks how many times smaller is solid A to solid B. So yeah, 45/36 over 21. This gives me 216. That is, now this is all to the power of 3 to the power of 3. This is equal to a cubed. If I want to get rid of that cube, I have to cube root. 6 times smaller. This should be an A. Let's turn the page. Alright, you guys know how I like to say, oh, this part's probably easy. I think this is easier. The reason I think this is easier, because you're going to have to test, okay? You're going to change only one dimension, depending on what they give you. So that means you'll have to know the formula. You have these formulas in your notes. The thing about testing is you decide what numbers you put in there. Okay? So make them easy. Make them easy numbers. Okay? That's why it says in this situation, choose test values. You're going to choose the numbers you're going to put in there, but you're only going to change them according to what the question gives you. So for instance, on your example, you have number 9. How many times larger is the volume of a cylinder if the height is doubled? Okay, well, here is the equation for volume of a cylinder. We're going to change the height. I'm going to make it really easy. I'm going to choose 1 for the radius and 1 for the height. Easy. So I don't have to worry if I'm going to double it. I'm just going to multiply the height times 2. So here's my original. My original is simply 1 squared times 1, which is 1. 1 times pi is pi. So the original is pi. Now, we change. We double. And we only double the height. If we started with 1, my new height is 2. So here, new equation filled in. 1 squared is 1 times 2 is 2, 2 pi. There are 2. So how many times larger is the volume of the cylinder, which means large over small. This is large and small. These cancel, and I'm left with 2. Let's go to number 10. How many times larger is the volume of a square pyramid if the base edge is triple? Okay, well, here is the volume of our pyramid. B is the base area. I'm going to make it super simple. It's 1 by 1 by 1. So base area is going to be 1. The height is going to be 1. Here it is, so we have 1/3. And we're tripling, right? So if we're tripling, that means we're doing the base area is going to be times 3. So, bam. It's an easy number to change. 1 times 3 is 3. 3 squared is 9. 9 times 1 is 9. And if I do 1/3 of 9, I get 3. Put them in their equation. If I divide this, I get 9. Pick your own values. Alright, for your homework, I'm going to give you 6 more problems on this one. So in total, between 11.1, 11.11 and 11.12, you're going to have 12 problems to do by next Wednesday, which I think is fair enough, given that each one has like almost 14, 15 problems each. So total, you'll have just 12. So for this assignment, you're going to have 3, 4, 7, 8, 12, and 13. I'll post it on the instructions anyways. Again, if you have any questions, I'll be glad to help you with any one of these problems. Let me know, or I can do one-on-one with you to help you through Google Classroom, Google Hangouts. We can video chat so that I can discuss it with you, or I can just set up another video.